Coming to units and measurement, theory part is completed. Now we can solve some numerical which are given in NCERT. Coming for the first question, fill in the blanks. Here it is, fill in the blanks. The question is, the volume of a cube of side 1 centimeter is equal to dash meter cube. 1 centimeter you must convert for meter cube. Meaning is, here 1 centimeter, 1 meter is equal to how much? 100 centimeter. But 1 centimeter is equal to how much? 1 by 100 meter. Then volume of a cube is equal to, in terms of meter cube means length into breadth into height. So here 10 power 2. Instead of 100 we can write 10 power 2. Or 10 power 2, this is L value. Then volume is equal to length into breadth into height. Means 1 by 10 power 2 into 1 by 10 power 2 into 1 by 10 power 2. That is, volume of a cube is equal to 1 by 10 power 2 whole cube. That is 1 divided by 10 power 6, 3 into 2. Meter into meter into meter, meter cube. 10 power minus 6, 1 by 10 power plus 6 meter cube can be written as 10 to the power of minus 6 meter cube. B. The surface area of solid cylinder of radius 2 centimeter and height 10 centimeter is equal to dash millimeter square. Understand the question. Surface area of a cylinder, formula is 2 pi RL. R value is radius 2.0 centimeter. L length, which is taken as 8. So 10.0 centimeter. 2 pi value, you know, 2 as it is, pi value is 3.142. Then use this formula. Curved surface area of cylinder is equal to 2 pi RL. 2 pi, 2 as it is, pi 3.14 into R value is 2. Write it into L value is 10 centimeter. Right here. Multiply 2 into 3.14 into 2 into 10. I'll get 12,568 centimeter cube, which is there in centimeter cube, but here they have given blank in millimeter square. So 1 centimeter is equal to 10 millimeter usually. Then here millimeter square they mentioned. So 10 into 10 millimeter square. 10 into 10 whole square. 10 into 10 and 10 into 10. How much? 100. Right? So for this value, how much I must multiply with into 10 square or into 100. Then it becomes 1256800 millimeter square. So in terms of 10 power 4, if I take here 1.256 is there. 56 means greater than 5 number it is. So I need to round off this number for 0.6. So then 1.26, these terms I have taken. Remaining 6800, these all are considered as a 00 because next proceeding division I have taken. For the next division I have taken like 5, more than 5 it is now. So I added 1 for this. I made it for 1.26. Now 10 power 4. Instead of this, for the decimal point I have taken here. So 10 power 4 millimeter square. Next, a vehicle moving with a speed of 18 km per hour covers dash meter in 1 second. So here it is there in 18 km per hour. You must convert for meter per second. So here 1 kilometer is equal to 1000 meter and 1 hour is equal to 3600 seconds, because in 1 hour we have 60 minutes and for 1 minute we have 60 seconds. 60 into 60, if we multiply, we will get 3600 seconds. Come here, speed of a vehicle is equal to 18 km per hour. 18 as it is, kilometer to meter we have to convert, so into 1000 by per hour you must convert for second. So in 1 hour 60 minutes, in 1 minute 60 seconds. 60 into 60, 3600. Here two zeros gets cancelled. Here it is 2 5s, here it is 2 18s, 36. Then this 18 gets cancelled. 5 is remaining here. So that is 5 meter per second. Next, the relative density of lead is 11.3. Its density is dash gram per centimeter cube or dash kg per meter cube. So suppose density 11.3 gram per centimeter cube has given. Then 11.3 as it is, but from the gram you must convert for kg. So into 10 to the power of minus 3, because 1 kg is equal to 1000 gram, right? So 10 to the power of minus 3 it is. And here centimeter cube to meter cube. So 10 to the power of minus 2 whole cube. That is 10 to the power of minus 2 whole cube means you'll get 10 to the power of minus 6 kg per meter cube. So here minus 3, here minus 6 is there. Minus 3 gets cancelled. Minus 3 will remain here. But if you take this 10 to the power of minus 3 upside, then 11.3 into 10 to the power of plus 3. Minus 3 becomes plus 3 kg per meter cube. Or if I move this point, or if I move this decimal point one digit, then 1.13 into 10 power 4 kg per meter cube. Fill in the blanks by suitable conversion of units. 1 kg meter square per second square dash gram centimeter square per second square. Now 1 kg meter square per second square. Now just write it 1 as it is into kg means kg to gram means 1000 you have to write. Meter square to centimeter square, 10 power 2 whole square by second square as it is. No change in that. Then it becomes here 10 to the power of 3, 1000, 10 to the power of 3 only. Here 10 to the power of 2 whole square means it becomes 10 to the power of 4, 2 into 2, 4. So here 10 to the power of 3, here 10 to the power of 4. Then 10 to the power a to the power of n into a to the power of n. A to the power of m plus n, 3 plus 4. 10 to the power of 7 gram centimeter square per second square. Next, 1 meter is equal to dash light year. 1 meter is equal to 1 divided by 9.46 into 10 to the power of 15 light year. If you do so, you'll get 1 by 10 to the power of 16 light year, because 9.46 is nearly equal to 10. Here already 10 to the power of plus 15 is there. So base, so 10 to the power of 16 it is. Then 10 to the power of minus 16 light year. Coming to next one, 3 meter per second square is equal to dash kilometer per hour square. Then 3 into 10 to the power of minus 3, because you are converting from meter to kilogram, meter to kilometer, 10 to the power of minus 3 kilometer per second square to hour square. So 1 by 3600 whole square. Then this is square of that. If you take according to the mathematics, 3 into 10 to the power of minus 3 as it is, this 3600 twice it is. So 3600. Here minus 3. Here 2 zeros gets cancelled. Here 1 0 gets cancelled. So 36 into 360 into 3 remains. If you multiply all these things, I'll get 3.888 into 10 to the power of plus 4 kilometer per hour square. Next question is G is equal to 6.67 into 10 to the power of minus 11 Newton meter square per kg square is equal to dash centimeter cube per second square per gram. Here you need to do is G value is given 6.67 into 10 to the power of minus 11 Newton meter square per kg square. See here, Newton meter square. Newton means kg meter by second square. Meter square per kg square. Okay, already meter square is there, per kg square is there as it is. But Newton is kg meter by second square. So just convert this. Here only kg. Here kg power minus 2. Only 1 kg is remaining. Kg to the power of minus 1 is remaining. Meter, here meter is there. Meter cube it is per second square. Now 6.67 into 10 to the power of minus 11. Here it is meter cube by kg per second square. Here meter cube means what? Centimeter to meter cube means 10 to the power of minus 2. 10 to the power of plus 2 whole cube by kg 10 to the power of 3. Okay. Here 10 to the power of 3 and 10 to the power of 3 here downside. Here 10 to the power of 11 and 10 to the power of 6 it is. So minus 11 plus 6 minus 3. So it becomes minus 3 minus 11 minus 14. Minus 14 plus 6 minus 8. So 6.67 into 10 to the power of minus 8 centimeter cube per second square per gram. Next, a calorie is a unit of heat or energy. Calorie is the unit for heat or energy because heat and energy have the same SI unit and CGS units, and it is equal about 4.2 joule, where 1 joule is equal to 1 kg meter square per second square. Suppose we employ a system of units in which the unit of mass equals alpha kg, the unit of length equals beta meter, the unit of time is gamma second. Show that a calorie has a magnitude 4.2 per alpha per beta square gamma square in terms of the new units. So here first heat term once you have to take one side and energy terms you have to take one side. Now in SI system, N1 value is how much? 4.2 joules. M1 is how much? 1 kg, right? L1 is how much? 1 meter. MLT, in terms of MLT we have to mention. So here 1 kg. L1 is 1 meter. T1 is 1 second. New system N2 we don't know, right? M2 alpha kg, L2 is beta kg, T2 is gamma second. Why I have taken alpha, beta, gamma? Here they mentioned here 4.2 per alpha per beta square per gamma square, right? Now equate this and this. Then here dimensional formula of energy is m1 L square T power minus 2. Now comparing with constant terms, m power A, L power B, T power C, we get A is equal to 1 because A value m power A is equal to m power 1. A value becomes 1. L power B is equal to L square. B power becomes 2. T power C is equal to T power minus 2. C value becomes C is equal to minus 2. Now N2 is equal to N1 of these equations. This by this you have to write M1 by M2, L1 by L2, T1 by T2. Powers as it is. M1 by M2 power A, M2 L1 by L2 power B, T1 by T2 power C. Because we have the formula N1 into U is equal to N2 into So n1 into u1 is equal to n2 into u2. So according to that we have mentioned here. Here n1 value is how much? 4.2, right? N1 value is 4.2. M1 is how much? 1 kg. 1 kg. M2 is how much? Alpha kg. Power 1. Next, L1 is how much? 1 meter. L2 is how much? Beta meter. Power 2. B value is 2. Next, T1 is how much? 1 second. T2 is how much? Gamma second. Power C is equal to -2. So if you simplify this, you'll get 4.2 into per alpha per beta square gamma square, right? Next, explain the statement clearly. To call a dimensional quantity large or small is meaningless without specifying a standard for comparison. In view of this, reframe the following statements wherever necessary. Here see, whenever a quantity, we cannot say directly like which is small and which is less. According to dimensional quantity, whenever we are saying it is large or small, we have to compare with another thing and we have to say. So some sentences are given here. So which is correct, or if the sentence is not correct, you have to compare it with the a small thing or larger thing. For example, atoms are very small objects. See, just they mentioned atoms are very small, but they did not compare this for anything. So I can say atoms are very small as compared to the tip of a pin. See here, atoms are very small as compared to the tip of a pin. So this is not correct. What we can write? Atoms are very small as compared to the tip of a pen. I have to compare with something, another object. Then, a jet plane moves with great speed. A jet plane moves with great. Yeah, obviously a jet plane moves with great speed. But comparison is not there in this sentence. So we can modify. A jet plane moves with higher speed as compared to helicopter. See here, compared, right? Next, the mass of Jupiter is very large. Yes, usually the mass of a Jupiter is very large, but as compared to, they did not compare. Just come here, the mass of the Jupiter is very large as compared to the size of the Earth, right? Then fourth one, the air inside this room contains a large number of molecules. The air inside the room contains a large number of molecules as compared to that in 1 mole of a gas. Yes, in room we have a number of molecules as compared to 1 mole of a gas. Very small it is, 1 mole of a gas. Right? Next, a proton is much more massive than electron. Yes, the statement is correct. Then the speed of sound is much smaller than the speed of light. Comparison is there in this. So both are correct. A new unit of next question. A new unit of length is chosen such that the speed of light in vacuum is unity. What is the distance between the sun and the earth in terms of new unit if light takes 8 minutes and 20 seconds to cover this distance? So here speed of a light in vacuum is unity. Speed of a light. So what is the unit for speed? Meter per second. So here as the dimension of velocity are meter per second. This meter is related to length, right? And time is related to, second is related to time. So L power 1, T power -1, meter per second. See, here it is speed, but here velocity mentioned. But Speed is a scalar quantity, velocity is a vector quantity. But as compared to the SI units of speed and velocity, both are same, meter per second. So L power 1 T power minus 1. Since velocity of light in the new system is 1, T is equal to 8 minute 20 second they mentioned. 8 into 60, because it is there in minute, you must convert for second. 88 into 60. If you do so, 8 6 ja 48. So 480 plus 20 seconds. If you add these two, totally time is 500 seconds. Now velocity is in the new system is 1, right? So 1 is equal to meter per second. Meter is L power 1, T power minus 1. So L power 1 as it is, T power minus 1 means 500 power minus 1. So L value becomes 500 on new unit. L value becomes 500 on new unit. Therefore, distance of sun from earth is 500. Which of the following is the most precise device for measuring length? Here some devices has given. You have to say which is very useful to measure a device. Length to measure, which device is suitable for measuring length. A vernier calipers with 20 divisions on the sliding scale means it has a 20 divisions on the sliding scale. Then least count is equal to, we have a least count of the vernier calipers is equal to 1 by 20. If you do, I'll get 0.05 millimeter, or 5 if you write 10 power minus 2. Sorry, it is there in millimeter. A vernier calipers with 20 division on the sliding scale, millimeter. So converted for meter, 10 power minus 5 meter. A screw gauge of pitch 1 millimeter and 100 divisions on the circular scale. Least count is equal to pitch by number of divisions on the circular scale. Pitch is how much here? 1. Number of divisions on the circular scale is 100. 1 by 100. 1 by 100. So it is in millimeter, but you have to mention in meter. So 10 power minus 3. Then here it becomes 1 into, here 10 power minus 3, here 100 is there. 100 10 power minus 2. If you take here, then it is 1 into 10 power minus 5 meter. A screw gauge, an optical instrument that can measure length to within a wavelength of light. Wavelength of light. So wavelength of light is how much? 6,000 angstrom. Then least count of optical instrument 6,000 angstrom. Then 6 into 10 to the power of minus 7 meter. Angstrom in terms of a meter, if you mention, it becomes 6 into 10 to the power of minus 7 meter. Next, a student, out of these all three, which is more accurate means optical instrument is very accurate, because least count is very less for the optical instrument. So to measure length, the optical instrument is very suitable or precise instrument. A student measures the thickness of a human hair by looking at it through a microscope of magnification 100. He makes 20 observations and finds that the average width of the air is in the field of view of the microscope is 3.5 millimeter. What is the estimate on the thickness of air? Magnification formula. Magnification is equal to apparent size by estimated or true size. Here, this is the view, right? 3.5 millimeter, that is the apparent size. Okay, magnification is 100. They have given 100 here. We have to get estimated thickness. So formula is magnification is equal to apparent size by estimated size, but estimated size is question. So then take this term outside. Estimated size is equal to apparent size divided by magnification. Apparent size is how much? 3.5 millimeter. Magnification is how much? 100. If you do so, you'll get 0.035 millimeter. Next question is, answer the following. You are given a thread and meter scale. How will you estimate the diameter of the thread? How we will estimate? Then it is done by winding a known number of turns on a pencil, turns touching each other closely. Then the length of occupied by each single turn will be equal to the diameter of the thread. See here how to measure the diameter of a given thread, and by using a meter scale. How to estimate the diameter of that means you have to wound that, means you have to circle it completely. You have to circle that for a pencil and you have to get the diameter value. Next, a screw gauge has a pitch of 1 millimeter and 200 division on the circular scale. Do you think it is possible to increase the accuracy of the screw gauge arbitrarily by increasing the number of division on the circular scale? Yes, if number of division increases, it's more accurate. It becomes more and more accurate. So the sentence is correct. S, because the least count of the screw gauge is given by pitch by number of divisions on the circular scale. If least count of the screw gauge is inversely proportional to the number of divisions, as this number increases, least count will be very less. So which instrument is having very less least count? That is more accurate. So the sentence B is true. The next sentence, next C1. The mean diameter of a thin brass rod is measured by vernier calipers. Y is a set of 100 measurements of the diameter expected to yield a more reliable estimate than a set of 5 measurements only. See here, whenever you are doing an experiment, if you take number of readings, then the accuracy increases. Measured value, see number of times. If I take 3 times, accuracy will be less. If I take 5 times, accuracy little bit more. If I take 100 measurements, then I'll get accurate value, isn't it? So usually that what happens by taking the readings so many number of times, usually the accuracy increases.